Hello, good morning, and I'd like to explain to you the importance of logic, planning the logic of a program when you're making a game. So, programming and gaming, they all go together. You're trying to make a game, that means that you're actually going to be programming, because there are instructions, there are rules of every game. And so, for example, in football, there is one rule of the ball going, beyond a certain line, cross a certain line, and we call that the goal. So there are outcomes that are expected in games. All right. So without much ado, I'd like to explain to you the symbols that I use in the flowcharts. Okay. So when you look at what I have here, you can see that I have a few symbols that I'd like to talk about. So flowchart is spelled like this. Flowcharts. Okay, so the flowchart is simply I make use of a rectangle, and a rectangle is for actually adding the processes that if you need to really execute something. Okay, so any computation you need to do, any operation you want to do, compute something, do something. Are you okay? You use a rectangle to do that. Okay, so computations and actions. You call it that. So do one thing. Are you okay? 1 + 1 = 2. That thing, okay, or move something. Are you alright? That would be that. For the context of programming, I would like to use that definition. Then we come to the rhombus. So the rhombus is for getting inputs or outputs. So inputs or outputs. So if you want to set a value, you want to actually use the rhombus for that. Okay, I can give you examples, but for now let's just take it like this, and let me finish and see what we can do. So decision making, use the diamond shape. This is how diamond looks like if you haven't seen one before. No, I'm just kidding. Alright, so for decisions, so you realize that you need to make a decision at a point in the game having received the input. So if the input is too small or too big, or is on or off, if the light switch is on, it means enter. If it's off, it means do not. These are things that happen every day in our lives. So every programmer knows that this is like key. This way of thinking logically is very important for gaming and programming. Alright, now the arrow sign is actually used for programming flow. So from here, where do I go? From here, where do I go? So if I want to say that, okay, after I've done this computation, I would like to make an input. This is the way you do it. Okay, so you can see that immediately this computational actions have been taken, I make an input or I make an output. That okay, game ends. Okay, because you fell into a ditch. Here you get that. So that's a typical example. An example of decisions, like I said, will be a value being greater than or being larger than another. Okay, so if I do this and then I make a copy of this, and then what are you doing? Come on. Okay, alright guys, sorry about that. Coming back to my canvas, I think that object is outside the canvas. So that's the use of this arrow. We can actually use arrows to determine the direction in which we go as well. This is for the beginning and end of the program. So the program starts, or the game starts. Life is a game, isn't it? Alright, and then we can just put an arrow here, and once you've done that, it means the game has started. And so let's do some competition, let's do some actions, then we can also end it. Okay, so yeah, basically these are the 4 symbols. Let's carry on in the other video. Let's carry on. Bye bye. Hello. So LOGiC really means that we need to think through the different values and then look at what actions to take based on what value we have. For example, if a value is 0, we do one thing. If value is 1, we do another. So 0 could represent off and 1 could represent on. Alright, so we have an idle, a player being idle. So in this flow chart, we want to move from idle and then set certain values. For example, we want to say that our player needs to throw something. Alright, if our player needs to throw something, then we want to use this shape to represent that throwing. Alright, so let's add some testing here. Let's say that we've finished throwing. We don't want to actually start a game or pick something when we are still throwing. Are you okay? Can be picking something whilst you are throwing. You think about it, that doesn't cut, it doesn't make sense. So that's what LOGiC is all about. So let's make sure that the finish through value is a certain value that can change in the future based on whether we finish throwing or we haven't. So if finish throw is 1, then still throwing will be 0 kind of thing. Alright, so in flowcharts, the rectangles are used for actions, processes, and things that we want to do. Are you okay? And then the rhombus or the skewed rectangles are for input, data input. So I can add one more of that and change the value a bit. We want to also say that finish pick is 0. So finish pick is 0. We intentionally do that so that if we're not picking, we can set the value to maybe 1. So we'll be toggling it to 1 and 0. Alright, so as we go, let's move our decision making. So in flowchart, the decision making, the object used, the symbol used for the decisions is the diamond shape. Okay, so diamond shape, diamond. Yeah, you know how diamond looks like, right? And we're going to say that, okay, if my player is idle at the beginning of the game, I want to pick, but make sure that I'm not still in the process of throwing and that having picked something already. Okay, so because I'm already holding something, then I just finished picking something. So we want to have a way to control that. We probably wouldn't need a symbol, even though it's used in programming a lot. The overall shape is used for the beginning and end of the program, that kind of thing. So we start at the top and end at the bottom. Okay, so if there were a place to put this, we just put it on top, and then we just add some tests in there. We started. So we started, and then from there we want to be idle. And then whilst we are idling, we want to make sure that we have no ball being thrown, and then we're not still picking with, because we are about to pick. You can't pick something when you already picked it. So this is the whole idea of programming. To everything has to make sense. It has to follow a certain sequential order. So let's move all this intentionally to the left side. Everything we have here. Let's slightly move here. We're about to make a diversion. A decision is going to be made, and the decision made means you go down here or go to the right. Okay, so let's connect these symbols with an arrow. So we're going to grab ourselves an arrow. Let's take it here, repeat that. Arrow here. Let's take that there. We do it in such a way that these arrows are snapped to the symbols. Okay. So get an arrow, stick it there. And it's not snapping, so we can just grab it again. Strange that we're having two of these. Okay, great. So now we've done all these checks and settings, and we can now make the decision. So what's the decision? If we find out that we are actually holding the false, which means that we need to actually make another setting here for is holding. So we can just make a copy of this and stick it somewhere in there. By pushing these up, there's not a lot of space, but we can definitely have room for this one. Okay, so let's reduce the font a little bit, and I think it should be just fine. Reduce the font sizes. Okay, so we start with idle, and then we want to make sure that it's holding is true, is false. It's holding is false. If you are holding, then why are you picking? See the logic? You can be holding something and still be picking. Who does that? Alright, so we're gonna grab ourselves another arrow here. And then can adjust this one a little bit. So now it's looking okay. And then all we're seeing is that yes or no, are these conditions true? If they are, they want to go to the left, so that's a yes. So this is yes. Y for yes, and then N for excuse me. So and N for no. So if it's no, you go down here. Okay. So I'm gonna go on this path. If the two conditions are true. We're not holding and we're not finished picking. Okay, so there you go. The whole diagram is a bit cute, but we fix it. Let's not worry about that for now. We are thinking through how to proceed. There's no need to worry too much about trivialities. Okay, so let's get a copy of this box. We're going to use it. An action is going to be taken. So what's the action? If that is true, we just want to go ahead and pick. So typically talking about playing a pick animation. So the character is behaving like it's going down, that kind of thing, to grab something. So there you go. You can snap. Okay, snapped. And then since we picked, then we need to change certain settings. Excuse me. We set some new values as a result of the picking that we done. So what is it gonna be? So another way of making copies is just pressing control and then just dragging it. Okay, so what are these settings? Finish pick should be 1 now. It was 0, it's now 1. Then it's holding. It's false. What do you think? Can guess the value? What's it gonna be? It's holding is now true because you just picked it. So the whole idea of gaming logic is to just think like normal people do. Are you okay? Don't think in any funny way. If we're not holding, alright, then it means that, well, we need to do it again. So I would like to take this back to the top. So let me change this arrow here. I'm just gonna change the way I actually connect this. So just let's bring it down a bit and let's see if we can reshape this. It's not gonna be that easy, but it's doable. Well, it's not gonna be as easy as I thought. Alright, okay, find a better way to do this. Now let's connect up these ones. Space them a bit. Okay, so this is our flow chart taking shape. Right, connect that to there. Okay, snapping fine. The whole idea of the snapping is so that we could easily make changes. Okay, so as flowchart is helping us. This diagram is helping us to understand what is going on. It's very important that our head doesn't get cluttered, because you can be stressed out in trying to just understand how things work, and that is why you're doing this, using this graphical representation, a tool to help you to think in a more, a safer way, if it's anything like that. Because getting stressed means that you are not thinking right. That's the definition of stress by me, So we want to just make sure that our diagram looks fine, and we're going to make references to this diagram if something isn't working well in our game. Now we need a line to go all the way back up here, and we're going to look for an appropriate symbol for that. So let's try this. Okay, bingo. I think this works better than the other one. Okay, great. So we can just do that. We can just make this. So if yes, go in the right direction. If no, go back, do something else. And what is that? What could it do? What could it do? Repeat it. So I mean, this is flowcharts, right? This can apply to a lot of situations in gaming where you've got your character model and everything, but it's not working the way it's supposed to work, and gaming is all about logic. As you can see, gaming is all about logic. Alright, so I'll leave it there and prepare the PowerPoint, and I'll return back to where I was. Gaming is our rules. Okay, as for the model, we can always create a model, as you can see over here. You can always create a model. Hey, okay, I was somewhere else. Sorry about that, guys. So I'm back, and this is it. These are flowcharts, and we can look at it, and it will help us to think. We can from here write our code. So in another video we'll talk about that. For now, this is how you use Word to create your flowchart, to help you think straight, to make your game more sensible, and should make sense. Every game should make sense. It doesn't make sense. It's frustrating for the player, those who are playing the game. Okay, thank you very much for this video, and leave comments, and don't forget to do one thing. You can guess what that is. Don't forget to subscribe. Goodbye.